Welcome back. Today we're going to talk about solving and working with linear equations in two variables. In addition to solving them, we are also going to be graphing them, and we're going to work with a couple of different forms: slope-intercept form, standard form, and we will also introduce point-slope form. So let's start with slope-intercept form. It's a form you guys are very familiar with. The y equals mx plus b, where m, the coefficient on x, is our slope. Of course, slope is our rise over our run, so having m in some sort of fraction form always helps us out with that. And our y-intercept is the b, but we will always talk about our y-intercept as an ordered pair, 0, b. Okay? So, for example, we may ask you to graph y equals negative 2x. Plus 3. So we already know our y-intercept is at the ordered pair 0, 3. So we can go ahead and plot that particular point. Our y-intercept is 0, 3. And then our slope, since m is negative 2, that was a really bad negative sign, negative 2 over 1, we will rise negative 2 and run 1. And we can do that a couple of times. We can also rise positive 2 and run negative 1. So we know our slope is negative 2, and we've got 3 points, and we can connect them with a straight line, and that is the graph of y equals negative 2x plus 3. So any ordered pair that's on this line, any x and y, will satisfy or will work in this equation. So if we grabbed any x and y, like an x of 2 and a y of negative 1, I think that should work based on what I have on my graph here. So if we put 2 in for x, we'd have negative 2 times 2 plus 3 equals, and our y is negative 1. So the question is, does that work? And yes, it does. So negative 1 equals negative 1, and this satisfies, this particular point satisfies our equation. So another example, we might graph y equals 3 halves x minus 2. So our y-intercept is at the ordered pair 0, negative 2. So I'm going to graph this one in red. And starting with our y-intercept, we can use our slope, our rise over run. So m equals 3 halves. So I will rise 3, and I will run 2, and I will have a particular location. And I could also drop negative 3. I could rise negative 3 and run negative 2. Okay, so our equivalent slope negative 3 over negative 2, and I have 3 points, including my y-intercept and the graph of my line. New to this section is point-slope form, and point-slope form is generated from our equation for slope, for calculating slope. We know slope is y2 minus y1 over x2 minus x1 equals our slope m. Well, if we decided to get x2 over x minus x1 out of the denominator by multiplying both sides of our slope by x2 minus x1, okay, these would cancel, and we'd be left with y2 minus y1 equals m, our slope, times x2 minus x1. And that is point-slope form. And point-slope form works great anytime we have two ordered pairs. So if we have two ordered pairs, we love using point-slope form. Okay? We can also use point-slope form if we have one ordered pair, and that ordered pair is not the y-intercept. And slope. Okay? So if we have one ordered pair that's not the y-intercept and the slope, we want to use point-slope form. And if we have just plain two old ordered pairs, we want to use point-slope form. And here are some instructions on how to use point-slope form. If we're given two ordered pairs, we can determine the equation of the line using point-slope form. First thing we want to do is we use the two ordered pairs to determine the slope. Okay? So you know that anytime we have two ordered pairs, we can determine slope. And then we substitute that into point-slope form for m. So we would put it here for m, whatever our slope is. Then we can choose one ordered pair. It doesn't matter. Okay, remember we have two ordered pairs, right? We have x1, y1, and x2, y2. So we have these two ordered pairs. We can choose one of them. It doesn't matter. Either one will work. We choose it and we substitute the x value into the right hand x. As you can see here, we have two x's. Well, this is the right hand x. And then we would also substitute the y value from that same ordered pair into the right hand y. We want to get the right answer. We want to find the right equation. So we substitute into the right hand x and the right hand y. And then we can rewrite this equation. We can solve it for y and thus put it into slope-intercept form. And we will also ask you to be able to rewrite that and put it into standard form. So get those notes written down and make sure you have that and follow along as we do our process. So sample 1, given the points -2, 6 and 1, 4, determine the equation of the line, and we're going to begin with point-slope form. So first thing we want to do is calculate our slope m. So our slope is simply 4 minus 6 over 1 minus a minus 2. So 4 minus 6 is -2 over 3. So we have our slope. So then we substitute into point-slope form. Y minus y1 equals m, -2/3, times x minus x1. So we could choose either point. Doesn't matter which one. Let's go ahead and choose 1, 4. So that's our x. That's our y. We're going to substitute into the right-hand x and the right-hand y. So we get y minus 4 equals -2/3 times x minus 1. We're going to distribute the -2/3, which will give us y minus 4 equals -2/3 x plus 2/3. We're going to add 4 to both sides, so we have a fraction here, thirds, so instead of adding 4, I'm going to add 12/3, because that's the equivalent of 4. So I will add 12/3 to this side, and we get y equals -2/3 x plus 14/3. And there's the equation of our line in slope-intercept form. We'd have to do a little work on that to get that into standard form. Let's see if we have something that's a little cleaner in the next problem. In our second sample problem today, we're going to find the equation of a line with a slope of 2/5 and passing through the point 3, -4. Since our point is not the y-intercept, we're going to go ahead and use point-slope form again, but we have our slope. So this one will be a little bit easier. So using our point-slope form, we have y minus y1, so minus a minus 3/4, so plus 3 plus 4 equals 2/5 times the quantity x minus a positive 3. We'll distribute the 2/5, so let me copy down the y plus 4 equals 2/5 x minus 6/5. And we will subtract 4 from both sides. But 4, instead of subtracting 4, I'm going to do it in fifths, so I'm going to subtract 20 fifths. So we subtract 20 fifths from both sides, and we get y equals 2 fifths x minus 26 fifths. And that is the equation of our line in slope-intercept form. Now, if we wanted to put that into standard form, that would be easy enough to do. We would multiply everything by 5 because we need all integers. So we multiply both sides by 5. So we get 5y equals 2x minus 26. And then, well, since 2 is already positive, I'm going to subtract 5y from both sides. I'm going to add 26 to both sides. So I get 26 equals 2x minus 5y, or if you prefer, 2x minus 5y equals 26. And that's the equation of our line in standard form. Okay. Another kind of sample problem. Find the equation of a line passing through negative 8, 3 and parallel to 2x minus 3y equals 10. Well, parallel should tell us that we need the same slope. So we need the same slope as 2x minus 3y equals 10. So our slope here, it's in standard form already, so we'll do the opposite of a over b, okay, which is negative 2 over negative 3. So our slope is 2/3. And then we want it to pass through negative 8, 3. So we have a slope, we have a point. So we have a point, we have a slope, we can use point-slope form. And let's go ahead and input everything. We want to substitute our y into the right-hand y. So we get y minus 3 equals, we grab our slope because it's parallel to this line, 2/3 times x minus a minus 8, or x plus 8. So y minus 3, we distribute the 2/3, we get 2/3 x plus 16/3, and then we have to add our 3 to both sides to get it into slope-intercept form. So 3 in thirds, I'm going to add 9/3 to both sides. So y equals 2/3 x plus 9/3, and 16/3 is 25/3. And that's our final answer in slope-intercept form. Similar kind of problem, but now we want a line that's through negative 8, 3 and perpendicular to 2x minus 3y equals 10. So if we want it perpendicular, we need the opposite reciprocal slope. Okay. Well, our slope here, well, it's the same line, so our slope here, of course, is 2/3. The opposite reciprocal then is negative 3/2. So now we start again. We go back to point-slope form. We have our point, negative 8, 3, so y minus 3 equals, and then our new slope, our perpendicular slope, negative 3/2, x plus 8. Y minus 3 equals negative 3/2 x, 24/3. Pardon me, 24/2. I misspoke. Well, 24/2 is 12. So y minus 3 equals negative 3/2 x minus 12. We add 3 to both sides. Y equals negative 3/2 x minus 9. And there again is the equation of our line in slope-intercept form. We can multiply everything by 2 to get rid of the fraction. So we have 2y equals negative 3x minus 18. If we add 3x to both sides, we will have ourselves standard form. 3x plus 2y equals negative 18. So a quick review, forms of linear equations. Slope-intercept form, y equals mx plus b, where m is the slope and the y-intercept is the ordered pair, 0b. Point slope form, y minus y1 equals m times x minus x1, where m is the slope. You use it to determine the equation of a line when you're given either 2 points or you're given the slope and 1 point, and that point is not the y-intercept. If you're given the slope and the y-intercept, you might as well go right to slope-intercept form. 3, we have standard form, ax plus by equals c, where a, b, and c are integers. A has to be positive, okay, or a has got to be greater than or equal to 0. Our slope is the opposite of a over b, and our y-intercept is 0, c over b. Okay, and this is nice format when we're graphing with only the x and y intercepts. So there's our introduction to graphing linear equations and point slope form. We look forward to seeing you in class.